going to give a little informational briefing on a new development with the Pacific Arctic Group, which is a group, is a forum, basically, of interested parties, institutions in Japan, China, Korea, Russian Federation, Canada, and the United States to carry out cooperative observations in the Pacific side of the Arctic. The first major program that we really embraced was the development of this distributed biological observatory, which I think probably everyone knows about. And this was an effort to involve all of these different countries and their fantastic assets to actually take observations along some U.S. Sentinel stations around Alaska, using their ships of opportunity from our perspective, and to provide data that are stored at the Alaska Ocean Observing System. It's been a really fantastic effort. Our Asian partners in this Pacific Arctic Group had actually a lot of interest in information observations further north because they had felt that this region further to the north of the Chukchi Sea was instrumental in causing major extreme weather events in Eastern Asia. And I mentioned Asia first because that was, it has later been kind of adopted as a really big concern in North America as well.
Kathy, I'm sorry to interrupt. Are we on the next slide?
No, not yet. Next slide now.
Great. Okay.
Okay. So the Pacific Group, well, I guess that was on the next slide. Okay, so we share information and we undertake Pacific Arctic regional multidisciplinary syntheses of scientific findings, and we're engaged in project development. And this is where we are now. We're on our second major cooperative program, which is a much bigger ambition, I think, than the Distributed Biological Observatory. Next slide, please. In October of 2014, our Pacific Arctic Group, known as PAG, met in Seattle to review the accomplishments of the previous summer, to look at our Distributed Biological Observatory accomplishments, and then actually to set the groundwork for the development of a new observing needs in the higher Pacific Arctic that could provide valuable observations to forecasters and modelers of climate change impacts and surrounding the Arctic and reaching all the way to the mid-latitude. So it really has a much bigger reach, I think, than DBO. It's concerned a lot with changes in the Arctic, in the physical realm, impacts on climate not only there and the ecosystem in that piece of the Arctic, but also on the impacts on weather and climate in the northern hemisphere. The area of interest, which we had laid out in October, was this very large region going from an outer shelf of the East Siberian Sea and Chukchi Seas northwards to 80 degrees north, and extending from the Makarov Basin in the west to the Canada Basin in the east. So it requires the scale of the effort to gather observations about this really poorly observed region in the Arctic. It requires the assets from vessels, platforms, scientists, funding from many different countries to make it all work. Next slide. Some of the drivers, I guess the main drivers of this program are actually the concern about, well, of course, the meltback of sea ice cover in the Pacific Arctic, which our Asian colleagues call the hot spot of the Arctic, and also the consequent, well, maybe the simultaneous influx of warming Pacific water through the Bering Strait and warming Atlantic water, which is making its way around from Norway, Svalbard, all along the continental margin into the Pacific area. But what happens to the Atlantic water when it enters this Pacific Arctic side of the Arctic is not at all known, and particularly with ice gone, the actual elements of storminess have increased dramatically, and the potential for mixing in the ocean water column has increased dramatically. Atlantic water had in the past stayed down about 200 to 500 meters at depth and protected by an overlying freshwater layer. But the Atlantic water is known to have had an increasing amount of heat flowing in on it, like a highway of heat flowing into this area, as well as the Pacific water has doubled the amount of heat flux in the last 10 years into this area. Around the slide, you'll see some big yellow shabam blotches. Those are areas of major fisheries, and there's quite a concern as well, is that fish follow these currents. They're like the highways for them wherever they go. And we know in the Barents Sea, especially north of Norway, that the fish are migrating in significant distances away from their so-called traditional locations, and these are very important fisheries for the various countries. So there is a lot of economic concern about this whole region as well and what may happen. Next slide. One of the major inputs to this developing a study north of this region where the sea ice has gone back tremendously is that, again, the region, because of the warming of the Arctic, lowered the gradients of heat between the Arctic and the mid-latitude range, which makes actually the flow of the jet stream much less, slows down the jet stream because the gradients are less, allowing the jet stream to meander in its course. Normally the jet stream around the Earth was quasi-circular around at the limits between the breaking regions between the Arctic air masses and the mid-latitude air masses moving from west to east. But in the last many years, there's been very high amplitude excursions of the jet stream down into the mid-latitudes, which has led to extreme and long duration episodes of either heating and drenching range, as we've seen in Texas this last week, or in the wintertime where these, the forecasters call them the polar vortices that plunge down into areas of the northern hemisphere, such as East Coast U.S. Also, the extreme interest over in Asia is that they are also being subjected to these very low temperatures that are really huge incursion into their environment as well. And at the same time, in Alaska, for example, we get evidence that we have experienced unusually warm winters. So lots of extremes that seem to hang around a long time because the jet stream is just not moving very fast, but it is sort of sitting in one place. So you don't have a chance to really recover from these wild weather extremes. This is a big focal point of the Pacific Arctic Group's interest in gathering observations, because we can't forecast what's going on. Right now, we have a lot of statistics that correlate these jet stream excursions with events in the Arctic, but the physics are not well known, and therefore we need to gather observations in this area in the Arctic that we can input into models and to try to really beef up the forecasting of what is happening up here. Extremely important. Next slide. This slide illustrates that where the Pacific Arctic Group research cruises have been already in the Pacific Arctic, the interest is now trying to get all of these different countries to work together to work on specific climate ecosystem lines where we can depend upon the data coming out and in different geographical areas at the same time and try to find out this whole synoptic events that are happening over this region. Next slide. There's a lot of questions. We don't know where the Atlantic water is going in the Pacific Arctic. We know I set a big green arrow in the upper left, Atlantic water question mark. We don't know where it goes, the pathways it follows. We have the Pacific water, which From the U.S. perspective, for all these years, we're only focusing on the U.S. side of the Chukchi Sea and focusing on the water going out the Barrow Canyon, but there is a significant outflow from the Bering Strait waters out the Herald Canyon, Herald Valley, in this map is shown, on the Russian side of the Chukchi Sea. And the direction in which it flows is really variable, depending upon winds, forcing factors, a lot of different things. But we don't know where the Pacific water, if it is mixing with the Atlantic water and allowing extra heat to flux up to the surface to really exacerbate the whole issue of the sea ice warming and melting in this area. So this is an area that we feel we need to do. The next slide. It's just some data that collected by our Japanese colleagues that illustrate some of the differences, the variances of flow from the Herald Canyon side of the Chukchi Sea out. On the top illustration, you have Pacific water coming out the Herald Canyon moving to the east, buoyancy-driven currents. But then when the winds change, if you have wind forcing events, like in 2008 at the bottom of the screen, Pacific water is moved upwards, northwards. And it's almost as if it's a very rapid push because we develop a super high pressure zone over the Beaufort Sea, and it's like an express jet of this water up into the Makarov Basin and out. We're experiencing this area, so it's highly variable. Right now there's so much less ice, many more storms, more mixing possibly with Atlantic water. And this could have even more intense feedback to the solar incoming radiation when you have this lateral transport of heat through the ocean currents. Next slide. Okay, maybe this is too much oceanography for all you guys, but anyway, it's a time series. At the bottom axis illustrates time from about 1990 to 2015. Of an area on the Chukchi Plateau that shows the increase in the heat flux on the surface. That's this heat going in there. It's a combination. We haven't been able to parse it out, how much is attributed to solar radiation, how much is attributed to lateral heat flux through the Bering Strait, and also from potentially, well, Bering Strait in this one. We know it's increasing. It's getting thicker over time, this heated upper layer of the ocean. Koji Shimada from Japan is looking at major oceanic heat release events, in which he says is, well, very clearly in his mind evidence in 2007, 2008, which were really extreme loss of sea ice. So the heat coming from below, we do know that from our ice mass balance observations, that the ice is melting in the spring, early summer. Most of the melt is actually coming from warming water underneath the ice. Next slide. Okay, as 6 countries, we have proposed to do the near impossible, to get us all coordinated with all of our vessels and to link everything up to do some climate observing sections, I would say climate ecosystem observing sections. And these are lines that were drawn by our Japanese colleague from Koji Shimada, and you will see that it extends really from the East Siberian Sea, Makarov Basin, over to the Beaufort Gyre. So it really include efforts from all of these 6 Pacific Arctic nations to carry this out. We're in the process of beginning a pilot effort this summer, but we have not readjusted our own country's ship tracks accordingly this year. That will be another, probably in 2017, we will work on that. But what we are working on is gathering our data in this year and trying to look at the variability over the space and over the space at a similar time. Next slide. We also have a plan in this effort to integrate new atmospheric observations over the Arctic Ocean, because NOAA and other countries really support numerous Arctic atmospheric observatories around the Arctic Ocean. And some of these are this part of the program called ISOA. We realized that we really need to build inwards to the Arctic Ocean to gather the information about the state of the atmosphere and how it changes over the Arctic Ocean itself, and to link this information to those other stations, Cherski, Chixie, Dodonkula, Pallas, New Ellison, all these other stations that are marked in these green ovals